And because it is so cold, it's very interesting to see some of the things it affects. Now, one of the things you can demonstrate as far as change of state goes is because it is so cold, by mixing it with water, you can see a change of state that's very interesting. By adding a little water to the bag,
Liquid water.
and then adding nitrogen, what you're going to see here is you actually see two changes of state. You see the liquid nitrogen on top boiling, but you also see the water underneath freezing. And as it's mixing together, the water is changing to ice, as here, as the nitrogen is boiling. Why it does that is because nitrogen is so cold, it causes that water to freeze that quickly into ice.
So I imagine that as this liquid evaporates, turns into a gas, it takes up some more space.
Oh, it takes up lots of space.
Okay.
And that's one of the things in working in cryogenics that you have to really take care of. Because as the liquid is expanding to gas, it takes up so much space that if you don't take care of that, it can be very dangerous.
Oh, okay.
Now, we can show a little bit of that by doing this. If I put a little bit of the liquid nitrogen into a bag, and then we actually seal the bag up. It's closed, the bag is closed, and there's no place for the gas to go, but inside, and as the bag fills up with gas, it's going to,
It popped right out.
Yeah. See, even this bag wasn't big enough to hold that liquid.
Wow.
So, obviously what we need is a bigger bag.
Need more space.
So, let's use a bigger bag.
Okay.
Now, one of the things you can do when I do this is that we actually can see how much gas we get from liquid by using a particular amount of liquid. In this case, we'll use a cup, or 250 milliliters. Put it in the bag. Then we seal the bag up. We'll see how much gas you get from that certain amount of, a given amount of liquid.
What's the size of this bag?
Now, this is a 45-gallon trash bag.
45-gallon
gallons,
trash bag.
or in cups, that's 720 cups that this bag could hold if it fills up. And we'll see, you can see how cold it's making the bag.
Yeah. Oh, wow. You feel that.
Oh, yeah, like ice.
So is the bag going to be big enough?
I don't know, I'm afraid now.
Actually, it is. This bag is just big enough to hold 1 cup of liquid converted to gas. Or in actual numbers, for every 1 cup of liquid nitrogen I start with, I get 700 cups of gas.
Wow.
Now,
that's amazing.
That's what happens when you put it in a flexible container, like a bag.
Yeah, nice and can expand.
But what happens if you put it in a rigid container?
Something that can't expand?
It's something that can expand.
I think we're going to need a lot more space. Do you think we have enough space?
Yeah, maybe we have enough space in this place. We'll see.
All right, let's see what you got.
Okay. We got our liquid nitrogen here. Put our liquid nitrogen in our bottle. Now, the pressure doesn't start building in the bottle because the cap isn't on.
Right.
But once I put the cap on, I better put it away in a safe place, otherwise we're going to have some problems. So we put the cap on the bottle, put it in my cannon. We step back.
Okay, we'll
can't
do.
see.
And you can hear the plastic getting ready to go.
Oh,
Whoa.
Whoa. Look at this.
That
This is
is
shredded.
all that's left of the bottle after it explodes.
This is a little bit of nitrogen is trying to get out.
Yeah, that's right.
It caused this much. Oh, my goodness.
Now you know why it's so important to know
Yeah.
that the gas expands that much when you work in cryogenics.
You don't put a tight lid on liquid nitrogen.
that was pretty cool. So liquid nitrogen evaporates and dry ice sublimes.
Yeah. Now remember, these are physical changes, so we're not changing what the substance is, just how its molecules are arranged.
So if we look at other substances, could we see how they all either melt, evaporate, or whatever at different temperatures?
Yeah, and I find that fascinating. But instead of looking at the temperature effects, let's look at the pressure effects.
Is that supposed to be less boring?
Can we agree on different?
No.
Well, then different it is.
Huh?
Let me show you a little graph here. This is a phase diagram. It's a plot of pressure on one axis, temperature on the other.
So this is a plot of temperature versus pressure.
That's right. And there are different regions. There's a solid region, a liquid region, and a gas region. Now, average temperature is about, let's say room temperature, 25 degrees Celsius, and pressure is about 1 atmosphere, and that puts us right here in the liquid phase. Now, in Chicago, this past year was pretty cold, yeah?
Yeah, and this one was a cold one. Lots of days below freezing.
Oh, don't remind me. A typical January day can be about -5 degrees Celsius, with the pressure being about 1 atmosphere, so that moves us over here into the solid region. Now, that's not too surprising. We see ice form on cold days all the time. Now let's see what happens when we increase the pressure.
That doesn't make sense. I mean, we just end up in the part that says liquid.
So,
So it's saying that we could melt a piece of ice just by increasing the pressure on it?
that's what the graph's telling us.
Will the pressure ever get that high?
No, it's going to take more than weather. Let's go find a place where we can see that happen.
Well, that graph was boring anyways.
I heard that.
Oh, sorry. I didn't feel a big change in pressure.
Well, like I said, it's going to take more than weather. With every step you take, you exert pressure on the ground.
So if there's ice in the ground, then I can exert pressure.
And that would cause...
The ice to melt, just like on the graph.
It's not so boring now, is it?
Well, let's just say it makes sense now. Do we get to skate?
Why not? It's for science. All of our weight is being exerted on this really narrow strip of metal beneath us, and that causes a huge increase in pressure. And that's enough to move us from the solid phase to the liquid phase. The reason ice is slippery is because stepping on it causes it to melt a little, which makes it really slick. And sometimes you can fall down.
Let me recap, and you tell me if I get it right.
Go for it.
A physical change occurs when the molecule of a substance changes its arrangement, but not its makeup.
Yes.
CO2 goes from being a solid to a gas, which is called sublimation.
Very good.
Okay. Other physical changes includes a solid going into a liquid, melting, just like an ice going into a puddle of water.
Very good.
Liquid going into a gas is evaporation, just like we saw at the Fermi lab with the liquid nitrogen.
Yes.
And a gas becoming a solid or a liquid, this is condensation, just like the liquid outside of a cold glass or the iodine that you showed us.
Very good.
And that can all be summed up on a phase diagram, just like what we talked about.
Yeah.
So why are my ice cubes getting smaller?
Well, basically, they're subliming. You see, the temperature and pressure inside your freezer puts you near the transition between solids and gases. So, over a long period of time, they sublime.
And I can check that out on the phase diagram?
Oh, so you like graphs now. Cool. Well, let me show you the phase diagram for carbon dioxide then. So pressure and temperature are already marked. Where does that leave us?
In the gas phase.
That's right. And so when we have it as a solid, it goes right from being a solid to being a gas. We don't go through the liquid phase.
Okay.
And at this temperature and pressure, carbon dioxide is a gas. Now I can show you this with another substance too. I've got one here.
A pencil.
And
A ring. And that's a nice ring.
thanks. You know what these two objects have in common?
Hello, my name is Yao, and what is your name?
April.
I have two pictures here to show you. I have one of a pencil and one of a diamond. What do you think they have in common?
They both get EM points.
Hi, what's your name?
Megan.
I have two pictures. One is a pencil lead and one is a diamond. What do you think these two objects have in common?
They both have carbon.
I don't really know.
What do these two objects have in common?
Maybe that they both come from the earth?
What do you think these two have in common?
I think that the diamond is made of the same material as the pencil lead.
Oh, that's pretty good.
So these are both made of carbon, but they're different forms of carbon.
Is there a phase diagram for carbon?
Are you actually asking to see a boring phase diagram?
Well, think of it as a clarification.
You know, I'll take what I can get. So this is the phase diagram of carbon, and as you can see, pressure and temperature are already marked, and we're down here in the graphite region.
In that little corner?
Yeah, if you exert a tremendous amount of pressure, we can move from that into the diamond region. And now it's a different form of solid carbon, and those are called allotropes.